So, hello and sorry for the delay with the setup. Welcome to this talk about using large language model-based tools for testing. Or I could also say it is going to be a talk about vibe engineering. This is a term which was introduced by Simon Willison in a blog post a few weeks ago. And I have to very much agree with this conclusion that using these LLMs productively with a non-toy project is difficult and not straightforward. And in this talk, I will introduce some of my more and less successful attempts, how I used it for production code and mainly for tests. So why is vibe engineering difficult in the first place? And to answer that question, we can look at it from another point of view, that how are these LLMs different from the, let's call them traditional tools that we use for coding, but we have been used to for a longer time. And I pointed out 3 different aspects. The interface, their scope and behavior is also quite unusual, and they often produce misleading output. So let's look at all those in a bit more detail. So the interface is perhaps the most obvious one. We use human language to talk to these various tools. And of course, it has some advantages. At least for me, it's a big advantage that I don't need to remember exact syntax. And on the other hand, the phrasing still matters. So it's a less straightforward matter than it used to be with other tools. And perhaps even more weird part of the story is that these tools also communicate in a style which very much remembers of a human, but at the same time, in many cases, their reaction to an instruction and how they interpret it can be quite different from what you would expect if you told the very same thing to a colleague, let's say. But in my opinion, this interface is really the smaller of the hurdles. One very counterintuitive thing is the scope and behavior of these tools. If I compare them to other things like an IDE or Black or whatever we use for coding, they are much more powerful. They can do much more different things, but at the same time, they are much less consistent. So let's just consider how such a large language model-based tool, like it doesn't really matter whether we say Cursor, Copilot, Claude, whatever, how they compare to the Unix philosophy. So Unix philosophy said that a tool is supposed to do one thing, and it's supposed to do it well. In case of an LLM tool, it looks quite different, because now we have a tool which does really a lot of different things, but it switches, so the quality of its output varies a lot, both between tasks, and it's also inconsistent. So we were used to the things that, yes, the tools we use on every day in our job, they do have bugs and have some quirks, but these bugs are usually reproducible. That's not the same with these LLM tools. So I would say that this makes it quite demanding to work with them, that they behave like a human, even though obviously aren't, and they are a tool, but they don't really behave like the tools we have been used to. And then there is this third problem, the misleading output, and here I would like to mention my colleague Tanguy, who gave an excellent talk about presenting guidelines for these agents. And this is something which I had definitely experienced a lot of times, but I couldn't really name it until I saw this talk from Tanguy. And I think you know what I'm talking about if you have ever got this "I have successfully implemented" message from one of these tools. And then it turned out that, well, it was perhaps not that successful. So this, the unusual thing about these tools is that they often claim or even fake success when they weren't able to fulfill the request. And if we pause for a minute and consider how we would evaluate it for a more traditional code tool, we would probably say that it's an absolute no-go, that it says that, yeah, everything was successful, and then no. But in that case, it's a quite usual thing. And also, there is often this solution mode when they are providing something which seems to fix the problem, but if you look at it more closely, it doesn't. And that makes it also quite challenging to work with them, because you need to be much more careful and look at secondary signs, because just having a successful message at the end doesn't really communicate anything. So they can do much more, but you need to be much more active when interpreting their output. And part of this is, of course, due to the very big and ambiguous task which we want these tools to solve. So in many cases, you can't say with clarity that, okay, was it yes, now successful, wasn't it? But that's only a part of it. There are also a lot of cases when it's pretty obvious that the tool wasn't able to fulfill the request, and it still says that, oh yeah, successfully implemented. So before I show some examples, I would like to put it into a context a bit, because as we know, context matters a lot for all these tools. So I work as a senior engineer for Kepler, which is a data intelligence company. Right now, we have approximately 800 employees and 200 software engineers among them. The company has been growing quite a lot in the last years. We have offices in 10 countries, but are remote first. And it's perhaps also worth mentioning our engineering practices. So we follow pull requests and code reviews. We have, of course, a good test coverage, or as you might suspect from the topic of this talk. Then we have CI/CD pipeline, also dedicated DevOps team supporting the feature teams. We have every second week a knowledge sharing session, so that a presentation from Tanguy, which I referenced before, that was one of those sessions. And the usage of LLM-based coding tools is very much encouraged, but not required, which also means that we have licenses for various tools. And this is the point where I would like to mention that what I present is my experience, my opinion. If you ask other people from the same company working on similar code, perhaps they will tell something different. But again, that's very much in the nature of these tools. And yes, we are hiring, so please check out our current open positions. So this is the first example I would like to show. That was the prompt which I sent to LLM-based tool. And as a context, I provided only an existing test and this specification, what kind of tests it's supposed to generate. What do you think? What was the reaction of the tool? So I am showing this because I wanted to start with a successful example. This was actually something which went surprisingly well. It really generated six tests. They were all pretty similar to the existing one, and we could actually close this topic afterwards. Now a second, slightly different example. This was also successful. One thing I want to mention is that here I explicitly said that it should use it each. So this is jest construct. So this was TypeScript code. It each is a jest construct similar to the parameterized test in PyTest. And the reason why I needed to tell it, because in that case we had only a successful case and one test with authentication errors in the context. So it needed some guidance how to handle this one, but that went well as well. And one reason why I wanted to start with these examples is because I think that this is something where a lot of production code can use some improvement. So I think in the last, let's say, 5-6 years, I haven't run into a production code repository which didn't have tests at all. So I guess they exist, but that's definitely not usual in the repositories which I saw. So all repos have some kind of tests, and I would say that one thing which makes a big difference between them is how thorough this coverage is, how good is the safety net that they provide. And often this difference comes from not having just one test which verifies one happy path, but verifying multiple different valid input combinations and whatever. And the second reason why I presented it is because it is also something where LLMs are very good. So if they have an example and should generate more code based on that, that's something they do really well. So a frequent workflow for me when I write tests looks something like that I ask the LLM to generate the first test case. It's usually a good starting point, but I'm not quite happy with that, so we iterate on it quite some rounds. And then that first test reached the status where I think, okay, that's ready for review now. Then I start with a request which was like this, and ask the LLM to generate more tests following the same patterns. So this generating code based on example is probably one of the biggest strengths. So if they can copy existing patterns, they will do it pretty reliably. Now, the difficulty starts when it needs to decide whether it's worth introducing a new structure or not, and which structure they should introduce. And an even bigger difficulty is when they should evaluate that an existing pattern really shouldn't be copied for whatever reason, because it very much looks like that these tools aim for consistency. So if the existing code followed one pattern, then they will try to push the new code also into it, whether it's a good fit or not. And one thing which I miss even more is that explicitly pointing out when an existing pattern is problematic. So that's something that would perhaps happen more frequently from a human collaborator and happens very rarely from these tools. Now there is perhaps the most obvious use case. We have an existing code base, we want to implement a new feature, and of course we want to have tests for it as well. How well does that work in practice? In my opinion, it depends. And it depends mainly on the existing code. So what the LLM is trying to do is mainly trying to apply the existing patterns in the code base. And if it finds something which is good copying, then everything goes well. And at this point, I want to mention that both the article I quoted at the beginning and a lot of other sources emphasize that good engineering practices pay off a lot for working with LLM tools, so having tests, having linters, and test environments, and I definitely do agree with that. What I would add to this, that it matters even more to having the code itself in a good shape, because in whichever shape the code currently is, that's what the LLM will copy and regard as the example. So yes, it also means that if the code includes some problematic patterns, let's say some of the tests create resources which aren't used at all and are completely unnecessary, there is a good chance that the new tests generated by the LLM will do just the same. And if there is no existing pattern yet, then of course your mileage may vary how well it turns out. And again, as we mentioned with the test, it is pretty usual that the first thing, it is a good starting point, but it needs several iterations until it can be really sent for review. let alone put into production. Now, whenever we implement a new feature, we usually define the use cases. And in the first example, which I show, it was relatively explicit. Sometimes it happens implicitly. So I know people use both of these workflows. So some people first ask the LLM to come up with a specification and then to implement that specification. Other cases, we just say that, okay, let's implement that. But even in that case, implicitly, there is this step that the LLM comes up with some use cases what needs to be implemented in the first place. And that is, again, a very mixed bag. So I am the first one to admit that it often points out use cases that I have completely ignored. It also very often considers some, so to say, frequently occurring edge cases, like what if this is a negative number, and things like that. A funny side effect is that often it pointed out missing validation for me, that wait, it generated a lot of code handling negative numbers, but this should really be always something rather in the thousands. So these so much about the good point. The bit dangerous behavior is that it will almost always offer some reasonable default values and behaviors. A classical example is if the input is an empty array, then the output is also an empty array, which might make sense a lot of time, perhaps not for this specific use case, and it would be perhaps more helpful to clarify it, but it doesn't. Instead, it just generates the code with these assumptions, which brings us back to the previous point that we need to be relatively alert when working with that code and evaluating it. Then perhaps even bigger problem is that it doesn't really know your business domain, or perhaps, I'm not sure, perhaps in other business domains there are better experiences, but it is often very much off what is a reasonable value for tests in that case. And in my eyes, the even bigger problem with that is that it assumes that it knows your business domain, so it doesn't ask that, hey, for this function, what would be a reasonable input value? Instead, it just assumes some things and goes on. Now we have perhaps heard some of these comparisons which say that an LLM is a bit like an intern, which can do a lot, but doesn't, but also does some very surprising mistakes. I would say that there are some professional practices that probably many human developers follow, but LLMs, and are definitely encouraged to follow, but LLMs very much avoid. And the first of this is raising problems in the requirements. I have definitely managed to enter some prompt which didn't really make sense, or there was a mistake in it. I have never received a safe, straightforward response that, oh yes, that's, wait a minute, what is it here? The very related one is raising contradictions. If we have multiple parts of the requirement to existing code and they contradict each other, from a human developer, we would expect that they say that, oh, that something is funny here. Again, the LLM rather tries to find a workaround and have some solution for it. So in German, we have a saying that squaring the circle. It's something it will attempt to do. And the next point is finding the root cause instead of symptom patching, which again, we usually encourage human engineers to do that. LLMs mostly fail on it. And one critical one is asking clarifying questions, and very related to it, taking a break and stop if they recognize that, okay, I don't have enough information to solve this problem. So very much related to that, I wanted to mention some traps to avoid and to watch out for when working with these tools. And yes, the first one is that they often take shortcuts. So when it looks like the problem has been solved, for example, the tests are green, that's a good indicator, but not enough. So it still need to look at it in more detail. Very close to it is the problem with hacking the coverage, that they often introduce some tests which execute a lot of code, but verify way too little. For example, once I asked it to generate some tests for a CLI command, and yes, it generated which checked that the return code is 0 in the success case. That's fine, but that command was supposed to create like 5 different directories with 20-something files in them. So just verifying that, okay, it returns a 0 doesn't really add much value. And these are the cases where they can make things actually worse, because it looks like, oh yeah, this method is covered, we have good tests for it. In reality, well. So if something isn't mentioned in the specification, it tries to fill in the gaps. That's, again, some that we have seen with the empty array. And if it finds something contradictional, it really tries to resolve the contradiction instead of just pointing out and stopping, because that doesn't really happen. So this is an example for me. I asked it to update a test, so that the test should also verify the author spans attributes and the span events. The only problem was that I copied the wrong function into the context. And but do you think what was the reaction for that? Sorry? Yes, oh, at the end it turned out to be. So I would start with the expected behavior. For me, this is a case for a one-sentence response that, hey, foobar doesn't have any instrumentation. Something is probably wrong here. What instead happened is that it recognized very well that foobar doesn't have instrumentation. It even asked how it should react, because it was in the system prompt that, yeah, it should ask questions. But afterwards, instead of stopping, it just went on looking around. And yes, it ended up deciding that, well, in that case, it should change the test, that it should change a completely different method, which does have author instrumentation, and problem solved. So what is often happening in this case is that the reasoning is very much visible in the output, and that's great for transparency. It's not so great for usability, because the important point just gets lost in a huge wall of text. And again, the behavior which is missing is the stopping. Now, with these kind of things, how can we mitigate it in AgentsMD? Again, I got some of these tricks I have been trying with varying success, I have to admit, from Tanguy. And we can ask it to emphasize if anything is weird, because that helps us to spot the things in that wall of test. Another thing is, actually the same thing is using emojis, for example, for this emphasis. I have tried this sentence, you always point out if something in the prompt sounds wrong. Not really happy with the results so far. And also, this asking questions is smart was in the system prompt. It didn't really bring what the expected result. And also asking it to stop when it runs to something. And this is what I would like to point out, that a very different behavior from a human. Because in the previous case, if a human spots this contradiction and asks the question that, hey, what should I do with that? It's very improbable that they will just continue working on it, and no matter what the answer is. But that's actually how, at least some weeks ago, that specific tool in that specific case behaved. Now, the next point is with this various tricks in the system prompt that it seems to be also very different how well the system prompt gets interpreted or not at all. And for that, I also was trying various tricks with various success. We can ask the agent to summarize the guidelines at the beginning. Another tactic is that if during the conversation it does something which is clearly against its guidelines, we can point it out. We can also try adding the agent's MD to the context and including a clause like follow your guidelines. These were all in the category it sometimes helps, sometimes it doesn't really. And sometimes it went to the other direction, then it followed the guideline very literally and asked questions about everything. So this is a very double-edged sword. So I wanted to share this example because I was very surprised by this. So here it implemented a feature reasonably well, but instead of a strict equal test, it decided that, oh, it's enough to just test that the output has a property. And this is a typical case for this hacking coverage category, and that happens unfortunately very often. Now the next point is troubleshooting. So if there are some errors, it is usually reasonably good at listing the causes of the error. What it's less good at, that often the list is a bit too huge. And then when it comes to fixing the problem, it often picks rather the shortcut. And for that, one tactic to mitigate is to ask it to separate these two phases, so the analysis and the fix. That is sometimes helpful. And I have just seen that we have only 5 minutes left, so I will go through this and instead jump to a positive example, because that one was also something which went reasonably well. So we spotted that in our tests, the setting of environment variables had sometimes unintended side effects. So we wanted to use monkey patch setenv instead, and this one worked very well. So it updated all the relevant tests, mentioned one case which was perhaps a bit tricky, and this is a task which makes the test suite much more reliable, would be kind of tedious to do it manually, and it's quite valuable. Again, another refactoring. This was a pull request comment from one of my colleagues that, oh yeah, this helpers module is way too big. We should probably split it into two. And a few years ago, I would have evaluated in such case that, okay, how much work is it to split it really? Now with LLMs, this works really quickly, and this is something they can do really well. So the next topic I wanted to touch on briefly is generating test data, because again, my experience with that has been a bit controversial. So I have asked it sometimes to generate, for in this case, quarterly data based on existing monthly test data. This tended to work well for small amounts, with sometimes errors in the arithmetic calculations. For bigger test files, it was hopeless. It usually ran into an error. So instead, what it can do reasonably well is creating a script to generate test data. And again, strong assumptions about the business domain, multiple iterations needed, the usual caveats, but this is something for which I have found these tools really useful. And this is very much related to this more general topic, this exploratory testing aided by automation tools. I have heard explicitly this phrase the first time in this podcast episode, so I linked it. But what they mean with it is exactly that kind of utilities that generate test data, set scripts for setting up infrastructure, scripts to execute test requests. These are, again, some cases where LLMs can be super helpful. And this is, again, an example just for this. I got this local test request from my teammate, and then I asked the LLM to create a shell script based on it and parameterize some of it so that we can use it for more versatile tests. Now, this was, again, something which needed some iterations. I will now skip through the details, but the first attempt was just a good starting point. But after some back and forth, we really had a test script which we can use reasonably well. So that's a use case for which I can really recommend them. Now, with technology choices, it's quite similar as with the troubleshooting. It can provide good input. It is more controversial when it comes to the opinion. And this is probably something which is, again, a bit difficult to work with. There is this tool which has that vast amount of knowledge, and then it comes to very strange conclusions based on it. So I have this general impression that they can extract information very well, also from huge sources, messy sources, but making sense of that information is not exactly their strengths. And 2 tips which I have when they ever say that, okay, from these 4 possible solutions, this is the one I recommend. I practically always ask for a reasoning, and usually I also ask them to refer to external sources, and yes, it has happened multiple times that it referenced PyTest docs or whatever, something which I really regard as a trustable source. So I would like to close with telling how LLMs change my testing practices, because overall it's, I would say, positive. So they were helpful generating end-to-end tests for cases which I probably just wouldn't have touched before because saying it's too complex. And similar in the case of unit tests, that for cases where the mocking is not that straightforward and you need to mock, I don't know, 4 different objects, I am much more willing to get started with it now with this kind of help. And some good candidates for tasks that to be solved by LLM include generating code following an example. If you like your example, probably you will like the outcome from the LLM as well. The other case is when you can very well much tell which technology you prefer for that use case. That usually also works well. Refactoring is something which is very relevant for this vibe engineering and good engineering practices, and where these tools can be super helpful, especially if it includes some very well-defined pattern, like we saw with the monkey patch setem, or if it's moving around existing code. And these automation tools aiding exploratory testing, I very much encourage using them. And yes, I would say that vibe engineering is viable in the sense that, yes, these tools can be really helpful, but it's very far from straightforward to figure out when and how to use them. So if you ask me whether you should use LLMs, so I would say probably yes, at least try them out, experiment with them. And if you ask me whether you should trust what they produce, the answer is definitely no, be skeptical. So thanks a lot for your attention, and now I'm happy to answer some questions if there are any.